We often assume that Earth has 7 continents, but in reality, scientists have long questioned this division. They believe that Earth harbors an 8th continent, home to entirely novel species and a completely unknown civilization. Through faint traces and relentless efforts, scientists have recently finally discovered the 8th continent. This place holds countless mysteries and enigmas, far beyond human comprehension. Currently, Earth has 7 continents: Asia, Africa, South America, North America, Europe, Australia, and Antarctica. However, scientists have discovered an 8th continent of Earth, called Zealandia. This is a continent located to the south of present-day New Zealand, near Australia, and is believed to have sunk to the ocean floor 75 million years ago. According to scientists' research, approximately 200 million years ago, the supercontinent Pangaea split apart, forming 2 new supercontinents, Laurasia and Gondwana. These 2 supercontinents then continued to break apart, forming smaller continents. Laurasia in the north later broke apart to form the continents of Europe, Asia, and North America. During the breakup of the supercontinent Gondwana, today's continents such as Africa, Antarctica, South America, and Australia gradually formed. Specifically regarding Zealandia, this continent broke away from Australia and Antarctica when it was still part of the supercontinent Gondwana. When Zealandia was still above water and began rifting away from the supercontinent Gondwana. This caused the continental crust beneath to stretch and thin, eventually submerging completely beneath the ocean approximately 23 million years ago. Earthquakes and volcanic eruptions are frequent in Zealandia because the continent lies on the boundary between the Indo-Australian and Pacific tectonic plates. The Southern Alps on New Zealand's South Island are part of the Alpine Fault, which marks the boundary between 2 tectonic plates. By mapping the ocean floor and analyzing the geology of the continent of Zealandia, the map provided by the research team shows that the continent's area reaches nearly 5 million square kilometers, equivalent to about half the size of Australia. However, only 6% of Zealandia's area is above sea level, comprising the entire territory of New Zealand and the French archipelago of New Caledonia. The entire remaining area lies deep beneath the ocean floor, making the survey work extremely difficult. In Zealandia, it has been proven that mammals once lived there after the fossilized jawbone of an ancient mammal species was discovered. Contrary to the previous belief that only species like bats, birds, and seals were endemic, both New Zealand and New Caledonia have far richer endemic fauna. According to this hypothesis, for many centuries before humans appeared on Earth, while most of the Zealandia continent was still submerged deep beneath the ocean, a completely different creature was the dominant force of this land. It all began in August 2020, when 3-million-year-old fossils were discovered on New Zealand's North Island. This fossil was identified as belonging to a uniquely colored penguin species, previously unknown to science, and was subsequently named Eurydice attatu. It is believed that penguins were once widespread across the Zealandia region when its surface was still above sea level. Earth's long-lost submerged 8th continent remains a controversial topic among scientists. The biggest obstacle lies in the fact that the oldest rock and shell samples found in Zealandia are only about 500 million years old, while all other continents contain crust dating back a billion years or more. Through the process of surveying the ocean floor, scientists have determined that Zealandia possesses all 4 key characteristics of a continent. The continental crust has greater thickness and density compared to the oceanic crust. This area features the presence of 3 main rock types: igneous, metamorphic, and sedimentary rock. With an area of over 1 million square kilometers and clearly defined borders. They examined 169 ronic stones that were retrieved from the submarine ridge beneath the New Zealand archipelago. This type of rock is formed from the crystallization of magma deep within the Earth's crust. By extracting the minute crystals from these stone slabs, they have determined the age of the oceanic crust in that area. The research results indicate that this 8th geological stratum was formed between 900 million and 1.3 billion years ago, and was part of an ancient supercontinent known as Rodinia. In other words, its age has contributed to shaping its current way of thinking. It is on par with other localities around the world that share a similar origin. Currently, scientists are striving to map the eighth continent and complete the necessary procedures for it to be officially recognized as a lordship. One thing we know for certain is that every place on this earth, there is a diversity of climates, ecosystems, and cultures. However, in the past, things weren't always like that. And in time, the day will come when our world changes so much that we ourselves can no longer recognize it. According to the theory of plate tectonics, the Earth's surface is composed of 7 major tectonic plates and many smaller ones. Stratigraphic formation. The construction network has a substantial track record. Tectonic plates are typically about 100 kilometers thick and consist of 2 types of crust, oceanic and continental. Beneath these 2 layers lies a continuously shifting, malleable mantle. It is this movement that causes the tectonic plates to shift in a process known as continental drift. The theory of continental drift was first proposed by Alfred Wegener in 1915. He observed that the coastlines of the 2 continents on opposite sides of the Atlantic Ocean could fit together, a prime example being the coasts of Africa and South America. Afterwards, Benjamin Franklin made a similar observation. The similarity between geological structures and fossils on different continents led geologists in the 1900s to believe that today's continents originated from a single supercontinent that existed in the past. Initially, this hypothesis was not widely accepted because people did not understand how continents could drift apart. It wasn't until the 1950s that it was accepted in Europe, and it took until the 1960s for North America to recognize it. The continental drift hypothesis became part of a larger theory, the theory of plate tectonics. The theory of continental drift explains why the continents look like the shattered fragments of a complete picture on the world map. The Earth's surface is composed of 7 major tectonic plates. These plates are not stationary, instead, they move at different speeds, ranging from a few millimeters to about 2 centimeters per year. This speed is equivalent to the rate at which human fingernails grow. Earthquakes occur when tectonic plates collide. Now, Earth's tectonic plates are in constant motion, causing the surface of our planet to change every day. Researchers from Yale University, USA, and the Japan Agency for Marine Earth Science and Technology say a new continent will form in 250 million years. Specifically, the continents of North and South America will move closer together, the Caribbean Sea and the Arctic Ocean will disappear, and Asia and the Americas will merge into a single landmass. The result of the movement of Earth's tectonic plates is the formation of a new supercontinent named Amasya. Based on autovision theory, this study was published in Nature after the phenomenon of supercooled separation was observed. The continents drift apart but are held in place by a belt where tectonic plates overlap. Currently on Earth, the Pacific Ring of Fire is this plate boundary, where a new supercontinent will be formed. To verify this model, scientists used paleomagnetic data to study the changes in the Earth as it rotates on its axis. These changes are formed by shifts in the planet's mass distribution. These changes occur over millions of years, through the process of the Earth rotating on its axis and self-adjusting to maintain balance while in motion. By integrating this data, scientists were able to make predictions about the supercontinent Amasya. The 3 continents of America, Asia, and Europe all converge in the Arctic region. The formation of the supercontinent Amasya will draw North America and South America closer together, resulting in the disappearance of the Arctic Ocean and the Caribbean Sea. As North and South America move northward to merge into a single landmass, Europe and Asia will also experience a major collision. Seafloor spreading. Based on a detailed map of the submerged mountain range stretching across the Atlantic Ocean floor, he used ultrasonic waves to survey the surface of this ocean bed. Harry Hess proposed that the ocean floor is in constant motion, with magma from deep within the Earth rising through fissures and being rapidly cooled by seawater. It turned into solid rock and slid down the 2 slopes of the underwater mountain. The shifting of rigid rock plates and subterranean flows within the Earth has caused the tectonic plates to change, pushing the continents farther apart. By analyzing raw satellite images, scientists have observed that the continents are shifting across the Earth's surface at a rate of several centimeters per year. This initial shift will cause the tectonic plates to change position and collide with each other. Hypotheses have been put forward regarding the initial displacement of North America, South America, and the land far to the west away from Africa and Europe. Geodynamic models indicate the possibility that the North American and South American continental plates will move in the opposite direction to their current one, along with the process of the Atlantic Ocean being subducted. In another scenario, the Pacific Ocean is subducted into the Earth's mantle, causing the North and South American continents to drift toward East Asia. In the future, today's continents will merge to form a single supercontinent. Based on a forecast by Chris Kotek, a professor of Earth and planetary science at Northwestern University, a new graphic study has shown that the continents will merge into a supercontinent in the next 250 million years. The chart shows that the low-lying areas gradually shrank and became distorted over time. First, the Australian continent drifted northward, while Africa moved increasingly closer to Europe. East Asia is beginning to shift westward, while Antarctica is drifting northward, toward the South Asia region and the eastern coast of Africa. Finally, North America and Western Europe merged into a single continent along the Atlantic. In 250 million years, current landmarks will be nearly unrecognizable amidst a vast supercontinent. On the other side of the Earth lies a vast ocean. According to scientists' predictive research, in 250 million years, the Earth will rotate slightly slower than it does now. Earth's rotation is gradually slowing down. By the time 250 million years from now, a day on Earth will be approximately 30 minutes longer than it is today. Sunlight will also increase slightly after another 250 million years. However, the most surprising result they obtained was that the global temperature would drop by as much as 4 degrees Celsius. In the northern part of the supercontinent, the snow and ice will form a layer of permafrost, persisting continuously through both winter and summer. This causes the surface temperature to tend to be a few degrees lower. This is not the first time in history that nearly all of Earth's landmass has converged to form a supercontinent. The last time this process occurred was at the beginning of the Permian period, approximately 273 to 299 million years ago. The supercontinent Pangaea was surrounded by a vast ocean named Panthalassa. The center of the supercontinent Pangaea is what we now know as Africa. Researchers believe that Pangaea was the third or fourth supercontinent in Earth's history. This supercontinent began to fracture and break apart into the continents we know today approximately 100 million years later, simultaneously forming the basin of the Arctic Ocean. Prior to that, the supercontinent Nuna formed approximately 1.8 billion years ago, followed by the supercontinent Rodinia, which formed